So basically, knowing enough about the guts of the TypeScript compiler to change your library code so that TypeScript ends up interpreting it just a little bit differently, and you get the results that you want.
Yeah. But like I'm just looking for like proper solutions, and I just try to fix bugs at the root of them. But this kind of thing is just like hard. Like this was just like there is no good answer. Like this is not a bug per se.
This is part 2 of a call with Mark from the Replay team and Andarist. In part 1, we talked about what Replay is and how it works, so if you're interested in that, go check that out. In this one, Andarist just shows how he debugs the TypeScript compiler. So he's a well-known contributor to the TypeScript repo, he's an open source guy, and he's done a lot of amazing work. And he uses Replay to do it, so he's one of the probably top Replay users. He's a power user, he's got over 1,000 recordings. So he shows us his method for doing that. Like for example, he uses 2 of them at once, and then we'll make a small change to one and leave the other untouched, and we'll just run them on the same inputs and see where they diverge. So there's lots of interesting techniques that he shows us, so it's pretty practical. And so in this one, we just jump right in, so enjoy. All right, so Andarist, you've been doing this with you're famous. You were doing this with the TypeScript compiler. I had a video on the channel people will see a few days ago with Ryan Kavanaugh. And he mentioned to me after the call that he would love to see, and other people on the TypeScript team would love to see how you use Replay to debug the TypeScript compiler. So no pressure, the team is watching. It's a pretty exceptional product for doing this kind of thing. There's not really much else out there. So yeah, tell us, how did you come into this, and like what's your usual technique or approach for using it?
In general, I was invited at some like beta stage to become a beta user of Replay by Jason. We knew each other from some open source work, I guess. We were talking on Twitter in the past, and he just knew that I was like into debugging. And so like he reached out and like he prepared a sales pitch of sorts. Like he was just describing the software, like what it is supposed to be, and like he warned me, that it's very like beta, it crashes a lot and all of that. But he assured me that it works, on the principle level, like it works. They were able to actually deliver the vision. The vision is just not stable yet, and like since like I was immediately hooked. It's like I understood what he's trying to just convey to me, like and like the implications of that for me personally. So I just started to debug just small things at my previous work, at my previous job, and yeah, it was working. It was crashing a lot, but it was working. Like I was just blown away by all of the implications of that. And so yeah, like I stayed in touch. I continued to use it. Probably reported a bunch of bugs and stuff like that. And it was crashing. Sometimes it was just unbearably slow and stuff. But like the value proposition was still just like so huge to me. So yeah, I continued to use it. And today it's just much more stable. Usually I don't even run into any crashes when I debug things. So the improvements are just like visible to the actual users on this front. And yeah, like one time, I guess, if I recall correctly, I just wanted to like debug the TypeScript compiler, and like I could do that with just bare Node, but yeah, like I knew nothing about the code base, and it's not the easiest code base to get into, especially at the beginning and stuff. So like it occurred to me just that I could use Replay, right? So
in theory.
So yeah, in theory, because like I was using Replay, like the browser, to record things well in the browser. So my thought was that, hey, we have this thing called TypeScript Playground, and I wouldn't even have to like set anything up because it's already a deployed page. So maybe I could use just that. The problem was that the TypeScript compiler on the TypeScript playground actually runs in a web worker. So that part was not implemented in replay at the time. Like it couldn't record like a different worker, a thread of sorts there. It could record, from what I recall, like iframes. So, multiple documents and stuff, that was working, but the worker thing was not. I just reached out to Jason, I think, and he pitched me like the secret project that, hey, yeah, the worker stuff is just not going to happen anytime soon because like it's not the priority, let's be honest. Mm-hmm. Like most people would like to use replay just to debug their like main thread.
Yeah, makes sense.
And he pitched me that yeah, they have this alpha version of the node recorder, and maybe I could give it a try. So I did, and as you can see probably on my screen right now, I recorded like over 1,000 recordings, and most of them are actually coming from like those are TypeScript runs.
Yep.
Some of those are throwaways because like I at times like recorded, some gibberish that I just wanted to like redo immediately. But yeah, it's still a lot of those here. This is just the TypeScript project. I mean the compiler itself, and I have like it's not the best workflow really, but like I have just a couple of throwaway files that I never commit kinda here. And this is like this kitchen sink file because like I edited, tweak and stuff, and I have like a minimal repro cases here and some things that I might want to revisit back. It's kind of stupid, but it works for me. So there's that. So
all right.
So I just have like a test here, and I called it my test because well, it's a kitchen sink, but I need for it to have some unique name. Sort of, and like no other test case in this repository is called my test because I want to filter the test run of Mocha, I think, in here, and I want to focus on this particular test file and on this very run. So I like there is a CLI for that replay node, and I can use like they have a task runner here which is called hereby. It's sort of like a custom thing, or at least it was born here when they migrated over from Gulp some time ago. Mm-hmm. Yeah, you have run tests -t and then you can write your filter. So I usually just go with my test here, and no lint because I want to like minimize the noise. And at the moment, no bundle is required. Because some time ago, like 2 versions ago or something like that, they migrated their build to use ESBuild, and it's just like this replay node is compiled against like a different architecture than ESBuild, so it doesn't work here. I would have to dabble with it more, but they had to make it work. But I learned from the team that, hey, there's just this flag, no bundle, and it skips the ESBuild and uses, I guess, like TypeScript itself to build itself or all of those test files, and it, compiles fine then, and also I just stick with that. I don't care about performance of that really.
Sure.
So I can start that. It actually, I think, like starts a couple of processes, and luckily-ish, the last one is the one that I'm interested in. So I think it actually, like, right now it records a couple of those processes, like all of those that were spawned here. But the last one that was spawned is the one that I'm interested in, and that will come like helpful in a second.
Are you talking about build services?
Yeah, like stuff like that. Like it's basically like a mock, I guess, and then like I don't know what it does in here. Like
All right.
Maybe it's just, sharded through workers and stuff. I recall like having some issues with that in the past. And actually, like, I think I committed to TypeScript like a change that allowed me to do it more easily, because you have like argfile thing there, like like the path to the process that has been used to execute the program. So I think that's exec path maybe, and they were using that already in a couple of places, but yeah, that's the one.
Oh, cool.
But they forgot sort of like in one of the places, so I just replaced like a hard-coded node that was here to the process exec path, and that just allowed me to skip like my custom thing that I was doing previously.
Cool.
Yeah, so it recorded. It took like it usually takes. It isn't so slow-ish here. I think it's just like we are recording this, and then it just takes more time on my machine. So now I just call replay view latest, and that's why I'm kind of like lucky-ish that the last process that I'm interested in is actually the test run, because well, view latest works out of the box, and I don't have to like find it in the list or something like that.
Yep.
So now I'm just starting the upload. It actually, it already like got uploaded. And
I love the hoverboard.
It boots up, and we should see it promptly. Yeah, the title is inferred from the process and stuff. So I can name it. My name test Michigan, whatever. So now, well, that's pretty much the same thing that Mark already like showcased, right? Because it's the standard replay UX. Like you have your sources on the left, you have the console on the right. I don't have the recording because, well, I recorded like the preview of my screen because, well, I recorded the node process. So hey, I just didn't record any
there's no video, no DOM elements, no React components.
Yep. Yeah.
So yeah, like we have the checker. That's the famous file
boy
for me because it's huge. It's the core of the compiler, of the type checking and all, and it's too big for GitHub to be rendered. So this checker, it's a huge file in the TypeScript compiler responsible for, well, type checking mainly and stuff like that. And it's like the heart of it. And it's just too big. Like it's a fun fact.
I like to make fun of the team because it's too big to view this file on GitHub. If you go to it.
I was exactly about to say that. It's funny because like GitHub won't have any problem when it comes to rendering like a package log JSON or yarn log and stuff, which is generated and it's already pretty big, usually like in a lot of projects. But this one, a handwritten file, is too big for GitHub to be rendered. So it is something.
Well, on a similar note, so Andarist is one of our power users and has reported lots and lots of actual bugs or requests for tweaks to our UI. But actually, one of the other things we ran into is that our original source file viewer that you're seeing and that you would see in the replay user interface didn't do as good a job of handling gigantic files. Something like if something was like a couple 100,000 lines long, we might end up trying to download all the data for that file simultaneously. And so because of cases like this, we actually went in and optimized our source file viewer so it does better virtualization, only downloads hit counts for like chunks of 100 lines at a time based on which portion of the file you're looking at, stuff like that. So like we've actually improved our user perceived performance for very large files because of files like this one.
Is it
because
Monaco
of
or
the-
CodeMirror or something? What is it using?
Neither.
Oh.
We actually used to use CodeMirror because that's what Firefox DevTools had.
Yeah.
And
Original.
one of my teammates is Brian Vaughn, used to be part of the React core team, and he joined Replay right after I did. And Brian is an expert on virtualized lists. He's written 2 different packages that are the standard for virtualized lists in React, including React Window. And what you're seeing here is actually just a very specialized virtualized list that downloaded all the source code and is showing you a chunk of the lines with the syntax highlighting.
Yeah. And
Wow.
I'm like very grateful for those optimizations because those made my life easier here by a huge margin. Yeah. So in here, we can just try something out. Like I have no idea what I even recorded, so I just
Well,
jump to some like random location. I don't intend to debug anything concrete here. But yeah, like I'm at the first hit of this get target of alias like expression. And what do we have here? Like we have expressions. So expressions are nodes in TypeScript. I mean, it's like a class and stuff. So those like most of the common entities here, which are just nodes, types, symbols, some kind of mappers, and a couple of others. They have special debug methods attached to them, and but they are only attached in dev mode, or maybe not like in dev mode, but like in debug mode. So another peer of mine just enabled this debug mode by like automatically by detecting replay, because replay comes with some global variable, a function perhaps. I have it here. Definitely, yeah, that's record replay and everything, like it's lowercase. So I just added that as this automatic detection. I could always force it, or I used to just replace that debug mode with a hard-coded true in the package.
Yeah.
This was like easier than remembering which environment variable I'm supposed to use and like how is it spelled and stuff. So I just went there, tweak it locally, and be done with it. But yeah, they accepted the PR, so that made my life easier as well here. And now they are all,
which is surprising, but very, very amusing.
Yeah, I extend my my gratitude to Jake Bailey who merged that, because the PR was open for quite some time, and Jake finally merged it at some point. And yeah, we have those debug helpers here. They are like most of them, they are accessible through other means, but they are not always like easily callable with the same set of arguments that those would use and stuff like that. So it's just like easier to use those. So for example, I suppose, because like I don't have a type information here, it is supposed to be an expression, so a node, and that comes with this debug get text method. And yeah, we have that. So we are like looking somewhere at React identifier or something like that. I have the call stack, so I can start just looking around and trying to deduce something, whatever I'm interested in at any time. A super cool feature for me, and I was also, I think, advocating for that, is continue to here, or like get back to here. When you hover over this, like to the right side of this gutter with the hit counts, you see this plus icon. So when you hit that, you can add your console log of sorts in here to this log point, and you can edit it and all. But I often like just found myself in a situation that I didn't want to like add this. I already knew roughly where I would like to be, so I had to like enable this, like trigger this pop-up, and then maybe, you know, click on this arrow here to jump to this. So if you hover over this, and now if you just press Command on Mac at least, okay, because I'm already past that point. So I rewind it, and now when I hover over it, there is this arrow, and I just can quickly click on it, and it will, you know, jump from whatever location that I was at to this here.
It's amazing. It makes it like every single line is its own breakpoint that you could call into existence.
Exactly. Yeah. And we have okay. So let's try that. Yeah, this is a type object. So that actually like that also has its own like debugging method. But this one, this debug type to string. And yeah, it's just type of React. So I don't know, it's a namespace or something. So it's not that interesting maybe, but you know, that's a string representation of whatever I'm looking at. But you can just inspect the thing, you know, a type in TypeScript compiler is just some object. So I can inspect whatever I want here. It's just good to have this thing, this printer, this printed thing, because, well, it's more readable and just faster to inspect things. There is a slight risk related to that I learned the hard way, that this unfortunately might be side effectful. So if called at the wrong time, when, for example, I don't know, like TypeScript is in the middle of resolving this particular type that I want to print, it might just like, you know, it's like I hit a path that they didn't predict because like it doesn't exist in the real code base really. So I might like re-enter the same function under the hood, and maybe then it triggers like a circularity, or it just caches a wrong value and stuff. So at times it is worth knowing that this is a side effectful thing, and it, you know, in a lot of situations it doesn't matter. But I had cases when it just botched my whole like debugging experience because I just didn't know about that, and I was observing like weird things, and I didn't know that is something to be just wary of.
It makes sense if the TypeScript compiler has never really been debugged in this way. With any tool, it's not a replay specific thing. It's just like
like that. They can run in the same into the same problem too. And I think like I've heard mentions of them running into that occasionally, but you know, it's not a big problem. And now like changing how this works just for the purpose of debugging might not be worth the effort at times and stuff. And if you work on this like long enough, you probably already know about the risk. And but it would be cool to like for this printer to, for example, like just avoid resolving things that are unresolvable. So for it to because like, for example, TypeScript at times creates objects, but they, like types for objects, for structured types, and they don't immediately set properties on it. That's lazy. So when I would call that before those get set, well, I trigger that resolution, so it gets populated. But I might not want to do that actually, because it would be useful for me that is like, this is some type that maybe has an alias and it could print like unresolved or whatever, you know, like as a helpful information. But yeah, there's nothing like that. And luckily, a fun thing about replay is that it knows everything about this recording. So when debugging with replay, I don't care even more, because I don't like, we have like a showcase what I mean. We have this links type here. Let it evaluate that. Yeah, so we have something resolved here. Let's assign undefined. Well, that's undefined. Hey, we just evaluated that on the server from what I understand. And I can make a step now, like nothing caused that to be like recached, reevaluated or whatever. Hey, here it is. Because like we actually like just this like abandoned the snapshot at which we were of like the snapshot of source. Yeah. So
try going backwards though and reevaluate it one more time.
It's gone. It's completely caching.
So let me actually try and talk through how this works a little bit.
Interesting.
The way the technology works is we created an initial process for the browser, or in this case, Node, up in the cloud. And during the initial setup process for debugging this recording, we run through it start to finish. We extract useful data like console messages, or in the case of an actual browser recording, like some of the what did the browser painting look like? Like what was the visual DOM appearance at different points in time? And we also create snapshots. I think now we do them like every like half a second or something. And so if I click on the timeline or I jump to a specific message or line of code at, say 17.2 seconds into the recording, our back end is going to say, okay, I have a snapshot copy of the browser paused at 17.0 seconds. I'm going to make another fork copy of the browser process, run it ahead 0.2 seconds, and pause at that line of code. And it actually persists that copy of the browser. And every time we run an evaluation here in the UI or via some of the methods provided by our backend, it's going to remember all the different evals we ran against that copy of the process at that point in time. So if I create a new variable or mutate something that was in scope at that point in time, that copy of the browser is getting its JavaScript environment mutated. So that one copy has been changed. But if I step forward to the next line, it's a different copy of the browser paused at a different point in time.
Yeah.
And it doesn't have any of those mutations applied to its JavaScript environment.
Yeah, that's very good to know. I thought like it would just be discarded. Like I didn't know about the extra like caching layer. Maybe it's not only about the caching on your side, but like
yeah. So like in theory, like if I go back, if I mutate something at pause 1, and I go somewhere else, and I go back to pause 1, and I evaluate the variable, it should still have all the mutations applied to that specific copy paused at that specific time.
And that's why we saw links.type still equals undefined when we went back. Got it.
Yeah.
Very interesting.
And like one extra thing that might at times like trip people, I think might be worth mentioning, is that like let's evaluate just a string here, so like it should come back, I guess it's an expression, right? And yeah, so we got it back, and now I can go back because I want to recheck something, and now I might want to evaluate something else. So second, well, it actually pops up above that because that's like the the timeline. Like it in here, it is actually. It was evaluated at a previous timestamp of like associated with that, with the hit and at this particular line. This was the second, and I evaluated the first thing here. So it actually puts that not at the bottom of the console,
order.
Yeah, chronological order, which is trippy at times, especially if you have like lots of
time traveling
and stuff. Yeah.
Time travel is great.
Speak for yourself, Mark. I think it's great too. Yeah.
You have this like clear console evaluation, so I often just after a while I discard all of them because often I just treat them as temporary. And yeah, this is basically how it works. You can
So you said that you filter, you called it my test. Where does that come into play here?
Because this is like, I guess we could maybe climb up the stack here. So if I wouldn't do that, I guess somewhere maybe compile files, what it is. No, that's maybe compiler test here. Like, this is not something that I look at often, but basically like this already like scoped to this test of mine. If I wouldn't do that, it would just try to record an execution of like 90K of tests. So, and like a replay probably wouldn't be able to handle that, although I don't know. I didn't ever try to do that. But I mainly do that just to like reduce noise, because otherwise, like it already, like even though I just recorded a single test, I can maybe get alias ID. Okay, like this has been hit, 60, like this thing here, 67 times. So
wow.
And that was just like a couple of lines of code. So if we multiply that with multiple test cases and stuff, like it's just a lot of noise, and I want to like as small as like debugging window that I can get.
Is there a point at which we would arrive back at the code in your my test file? Do you know what I mean? Like, is there a way to get to that code and then keep debugging, or are good debug from there, or it's not that way because first that code is parsed?
Yeah, it is parsed. Like it's just like it starts as just text. So I could go
one
to
big
the
string.
I could go to like the parser and probably see it here, but it's just parsed and it's bound, and then we enter the checker and stuff like that. So, and I'm usually like I debugged those other bits at times, but like usually it's just checker, and in here, I don't know, like usually it's like check expression, but perhaps this actual thing, we have some stuff, so we can go here. So what do we have here? Let's see. Debug.
Add a print statement.
Yeah, but then I will have like 10 of them. So it's like the symbol iterator, and I might want to, it's easier. It's also slightly, faster if I want to tweak, like evaluate things in succession, like different things here. So I guess, I don't like, it's like I'm currently stopped at a declaration of some array or whatever. But usually I'm just like able to focus on the parts that I'm interested. Yeah, we are in the interface string here, and this gets checked here. Use like this. This actually doesn't contain any expressions, so that might just not be like the perfect example for that.
Sure.
I can try to record something, a different
No, that's
thing,
okay.
like,
there's a part of me, having done this TypeScript stuff for a minute now, that really longs for a way to put a breakpoint here in this file, and like I don't know what it would do next, but I really want it to do something. I can't describe what that feature is.
It's
as a library maintainer, I would kill to have a step-by-step debugger at the type interpretation level. Like if I have one of the very, very complicated types in Redux toolkit that in turn is built up out of several generics and several subtypes and something, I would love to see, like, tell me what the first step of the interpretation results. Like, unwrap this type for me for step 1, for step 2, for step 3, so that I could see the sequence of it. I would kill to have that.
Like, I do exactly that. It's just, not automated. But yeah, like I literally do that. Like, I try to do that when I debug things here. It's not as easy as like hover over this thing and,
I think the difference is too that what you're showing is like This came up in a video a while back. We were somebody did the Conway's Game of Life in TypeScript types, and Orda, who used to be on the TypeScript team, joined, and we got talking about this. Just about every fourth video, we get talking about this topic because it's something library authors are really wanting. But what he said was, when we talk about like there's the string matching feature for, you can say like S extends and then some template string, and he was saying like, there's not really a way to make that into some sort of debuggable thing because it's like literally a string.splice in JavaScript in the TypeScript code base. There's not like a intermediary layer that TypeScript is compiled to that then is operated on. It's just like executed in JavaScript. And so I guess, Andarist, what you're showing is the best we can get as far as being able to debug these things, but it doesn't keep me from wanting it and dreaming of it.
Yeah, it would be hard. Yeah, you would have to like have some machine that would like in the code that would with stacks and all that would execute that. So yeah, like an intermediate representation, which would add overhead here, I think. So
something to observe.
It's not
at least
something to observe. Yeah.
Yeah.
I mean, one quick side note on that topic. So there's been several attempts to re-implement the TypeScript compiler in other languages.
Yeah.
One person who works on the SWC JavaScript compiler, which is built out of Rust, had two different attempts going on. One that was like a manual rewrite in Rust, another that was an automated translation of the TypeScript compiler source code from TypeScript to Go. And I've seen at least two other independent attempts to re-implement the TypeScript type checker system. One, if not both of those other attempts, actually, I believe, tried to convert the types to some kind of a bytecode, some kind of like a stack-based interpreter.
Yeah.
And, one, they actually appeared to have some nice speed ups, although they only implemented like a small piece of the TypeScript system. But, I mean, in a hypothetical world, maybe that bytecode approach could be used to implement like some sort of step-by-step debugger if it actually existed.
Yeah, the issue is always going to also be that there's no TypeScript spec. Like there's just the reference implementation. So
whatever it does right now.
Yeah, whatever it does. Which
like I'm surprised by those things like daily at times, and it's not even always obvious like to assess if it's a bug or if it's intended, because like there might be a reason why the surprising behavior is there, like some compat or whatever, even if it's not like completely correct. So yeah, the source code is the best thing that we have today. And then, like I got into all of this because I wanted to I didn't want to contribute to the compiler per se. Like it's cool, but like my primary motivation was just to be able to do this, like to debug this and to understand how it might be able to execute something, because like I was trying to implement some unusual types of source. Like I think like a lot of different libraries also implement some weird things. I mean, like complex at type level. Mine felt like simpler for the compiler, but they were just like simpler cases of inference failing here and there. And like, I was just like, hey, I'm not doing anything that special here. So like, why this is not working? And like, what makes it to stop working? Because I think that's a great strategy if somebody wants to get into this, or that's a great strategy for debugging, like in general, that like it was hard for me to get into this, and like it was a new world of sorts for me, and I didn't have a good anchor like to jump into there, like any point of reference that I would be interested in particular and stuff like that. I didn't know where I should be looking at. So makes sense. I debugged a lot of like similar runs, like I had two versions of the same code with a small tweak, and like one worked, one didn't. And I had replays like side by side and just switching from the left to the right window and just following them through. And since they were not behaving in the same way, I already knew, right? They have to be diverging somewhere. So I was just looking for that divergence, for that crossroad, and then following the trail and like inspecting why one went this route and another went this route and stuff like that. I was just doing that yesterday night with two replays because I was debugging some case. I had trouble to debug with like using other techniques.
Yeah, that sounds like a great way to use it, to have like a working version and then the known broken version, and you're kind of like bisecting and in real time through line by line. Yeah, that sounds like a great technique.
Yeah, exactly.
Where it really gets interesting, I've been saying since I joined that we are barely scratching the surface of what you can do with replay. So our debugger UI is built on our back end. And the back end is an abstraction over, jump to a point in time, spin up the browser processes, let it pause there. That API is public and documented, and anyone can write scripts that talks to the backend API. I've got an example repo that even has, like, here's just a Node script. Like I have one that downloads all the hit counts for recording and spits out code coverage information, for example. We have built our time travel debugging UI on top of that backend API. That's one way to use it. But when you start having multiple recordings, you could start to write deeper tools that pull out that data and analyze it in aggregate. We have an internal pre-alpha proof of concept right now that, for example, takes two different recordings of one end-to-end test. Like a recording that, like one copy of the test that passed, one copy of the test that failed, same test. And it actually interrogates the back end and tries to figure out like what JavaScript code executed and where did these two diverge? Like, did React render more than you expected? Like, was there an extra click? Did a network request come in too slow? And so we've got like an early proof of concept of that right now. But again, like it's totally possible to build this on top of the back end that exists today and start to, compare something about the execution flow of two seemingly equivalent recordings and figure out where they went in different directions.
Yeah, that will automate like half of my job here. So,
I know, like that's the cool thing.
Take my money, as they say.
Well, this has been really great. I mean, is there anything that we didn't touch on? Any big parts of this that we didn't cover?
What's like the coolest thing you found inside the TypeScript compiler?
Ooh.
That's a question. I'm not sure like what's the coolest, but like one of the weirdest might be was that so two maybe come to my mind, and I'm not sure if they're like cool as they just I like abused them in my code, so so for me they were cool. One thing is that we had like some nested inferences, and though we just had a lot of problems with those, like when when a generic function is called within another generic function. So like when TypeScript goes through that, like it encounter like they are nested, so it goes through like one resolve call and enters another one, and it actually might, like from theoretical or even practical point of view, like which inference is better? Like, should the inner one inform the outer one to like influence its result, or is it the other way around? Maybe the inner one wants only to benefit from the outer one. So there's no obvious like answer to that. So it just works in some way. But I think like related to that, I found at one time that it somewhere in the algorithm it replaces or like infers temporarily for one of such like type parameters and never type, but it's a silent never type. So like it shouldn't be observable by your code. It's just like an internal type. It behaves well like a never type for most purposes, but it's special in a way that it can be just distinguished from the never type. And I guess never is used because, well, it's assignable to everything. So that's a cool trait about it. And so while it shouldn't be observable, I observed it accidentally. And I was just able to resolve my conditional type through a different route, like to a different branch. Based on that information, and then I just knew like it's stuck on the inference, and I think it just meant for me that I am supposed to like choose the default because otherwise it inferred that never and it polluted the whole thing, something like that. So I was just able to abuse that. A similar thing is that in XState, which is like a state machine library, for executing state charts, and we deal there with those nested inferences because our API is just written this way.
Like many are.
Yeah. Like I guess with Zod and stuff, you have similar cases because like you can nest, like z.string within like z.object and like calls to those and like or whatever other function that you have there within Zod. So yeah, like this kind of an API, and we have actions like they are descriptions for something that we are supposed to call, like we'd update state by autocomplete, like somewhere within the state machine config, we could, do something like this. So this would appear in the outer create machine, and yeah, something like that, So, so this assign was producing objects because it was meant to be just a description of the change that we want to happen. And of course, like you can have like resolvers of sorts because we want those updates to be potentially dynamic and stuff. But it turns out that objects were not the right choice for us because they just didn't participate in that whole like nested inference algorithm in the way that we'd like for it to. So in V5, we refactored those assigns to be functions actually, which doesn't kind of make sense like from the implementation point of view and all. So I don't know, I could have updater or something like that here, and we have assign. So today we just do assign and updater. Something like that. So we treat it like for all of practical purposes, it's an object for us. But in practice, it's a function. So the return type of this assign, well, it's a function. So it has a signature, and that just makes TypeScript to follow a different path in the compiler, and it actually like behaves like we want it to. It gets resolved, like it benefits from those like outer inferences just like sooner, and it actually can benefit in our case because of that. So that was like something cool when it comes to like my daily job.
So basically, knowing enough about the guts of the TypeScript compiler to change your library code so that TypeScript ends up interpreting it just a little bit differently, and you get the results that you want.
Yeah. But like I'm just looking for like proper solutions, and I just try to fix bugs at the root of them. But this kind of thing is just like hard. Like this was just like there is no good answer. Like this is not a bug per se. It's the correct behavior. This is not a bug. So it just doesn't exactly match my expectations, which is unfortunate for me. But for the old purposes, it's not a bug. So I can fix it. Like I could expand on the heuristics used there and stuff to change the behavior, to improve it. But it's just such a like core vital thing of the compiler that it's super easy to just break something else in the process. So it's not obvious how to tweak that. Like the other thing with this whole like silent error type that I'd like to fix at some point. Maybe I need to like dig up the exact issue and all. And I think that TS pattern, if you have heard about that library, it's implementing like pattern matching in TypeScript, and it's also like quite involved at the type level.
Gabriel Vernard, he's been on the channel, and we're talking about doing a video with him on TS pattern. So I think like I told him about this never thing, and he benefited from that as well. Although he might have like removed that code from the, like he might just have like restructured the code since then, and maybe it's gone. But at some point he landed that as an improvement because he struggled with like a similar issue there, and was able to benefit from that. I'm super excited that we're sharing this now with the world, and maybe Andarist, we can have you come on and we can talk about TS pattern with Gabriel or something like that in the future. That would be super cool.
Disclaimer to the TypeScript team: please don't hate me. I don't want to abuse. I don't want to abuse all of that.
It's quite the opposite.
I sometimes have to.
No, I think they really appreciate. I really think they really appreciate your PRs and your work and effort. You're definitely one of the most high power contributors to TypeScript that's not on the team. There are others, but your name is hard to miss if you're looking through issues in the TypeScript repo, and you've done some amazing work. So we all thank you for that.
You're welcome. So, I enjoy what I do. So please send your cool bugs my way. I love to debug them.
Cool. All right. Well, thank you guys for coming on. This has been really cool. If anybody has questions, you can always follow up, and we're all available. We're all around. And until the next cool thing we come up with, we'll see you guys then.